It's so cool. I like to be able to come around and see other people's shops and what they do.
The well-known 4x6 bandsaw. And
wow, this is such a cool setup.
like, everybody loves the lathe. It's the cutest surface grinder you will find.
This might be the only RF45 with a heat shrink system in it, huh?
I have to find ways to do with the machines I have to be profitable.
Right.
That's already ground.
Look at that. You do it by hand?
Yeah, sure.
No.
Sure.
We're gonna disable comments for this video. Oh, look at that. It's cool. Hi folks, if you don't know Stefan Gotteswinter from YouTube or Instagram, you should. We are here in
Beratzhausen.
In Germany.
Yes, in Germany, of
and
course.
This is your home shop.
Yeah.
You want to show us around?
We're in the basement.
Cool.
Let's come. Let's start in the main shop with the manual machines.
This is so cool. I like to be able to come around and see other people's shops and what they do. You work as a machinist.
Yeah.
Or
I'm a full-time prototype machinist running CNC machine.
Yeah.
Doing programming and basically everything.
Yes.
And this is my my side business and hobby and just what I do.
Passion. Yeah.
Yeah, what I love.
The work you do on YouTube is really cool.
Yes, I do YouTube too, so it comes all together.
Yes. Cool.
Unfortunately, I cannot show my work stuff on YouTube because it's all R&D.
Your day job.
Yeah, my day job. That's confident.
Right, right.
I can't show that. But I can show you everything in here.
Cool.
So let's start over here.
Yeah.
We have large manual mill, RF45, like Chinese milling machine from German reseller Optimum. It has been a very good machine to me. It's a gearhead. It has lots of torque. Goes up to 3,000 RPM, so it's suitable for small tooling too.
Yeah. Nothing like the high-speed spindles, though, that are so common nowadays.
No, of course, absolutely not. But on a manual mill, there's always the misconception that you need very high speed for small tooling, and that's not really the case.
Really?
Yeah, you cannot get the feeds you need to run them at high speeds.
Interesting. So what when you say a small tool,
like a 0.5 millimeter.
You'll run really?
Yeah, I will run a 0.5 millimeter end mill on that and steel without a problem.
No kidding.
Yeah.
And you have acceptable run out or slop. It's okay.
I have on the tool. I will check the run out and I will tweak it to get it better than 10 microns.
Okay.
I will bump the collet, not if needed.
Yes.
Or bump the tool itself or clock it. Do whatever is necessary to get the run out done. Then it works. Fine. Yeah.
And there's not. Have you re-scraped this or?
No, I didn't. I scraped the gibs.
Okay.
Because
for better contact.
Yeah.
Or, okay.
And make them just match perfectly.
Yes. So you do that by simply bluing the gib and then fitting it and then seeing where it wears until you get better contact.
You put the gib in, snug it down slightly, and then you put an indicator here and here. From the fixed part against the moving part and you rack the table. Okay. So it's not by bluing, it's simply by feel. You measure it.
I see.
And then if you get 10 microns over here and 0 here, you know that you need to make your taper
thinner. Or more shallow. Right.
Yeah.
Okay. Interesting.
And that and then you scrape it flat again. After you did correcting against a known good master. I have a 640 by 400 surface plate in here under all the junk.
Kind of looks like our 18 by 24 size.
Yeah. Yep. Good quality surface plate, and you need some reference in the shop.
Right.
And for me, it's a surface plate. I can do a lot of measurements with an indicator and gauge blocks off the surface plate. I was thinking about getting a Tesa micro height or a Mitutoyo height gauge, but the work I do doesn't really comply to that.
Got it.
It's hard to measure like a 1 millimeter hole with it distance-wise. You can do it with tiny probes, but not sure if I really need it.
Fair enough.
Yeah, machine is really good to me. In the recent time, I did a lot of broaching on it.
Really?
Like slotting.
Okay.
Internal features.
Yeah. You'll put so not a traditional brooch, but rather a single point brooch.
It's a single point brooch, like, wait a second.
So you're just taking, I'm sorry I talk in inches, but you'll 1,000th of an inch y-axis movement, just kind of move over down.
And then you just go down with the quill and
just shaving off little, almost like a hand shaper.
This tool. This is used to cut an internal spline.
Yeah, sure. Look at that. Oh, that's so cool. And now, did you grind that tool?
That's ground on the debit grinder.
This is cool. We'll come back to this here in a minute, but I just have never really seen how simple it is to do some really, really cool things on this D-bit grinder. So we'll work our way around the room, perhaps?
Yeah, sure.
Okay.
So that's what I did recently. A lot of broaching of internal splines, rotary table, so you can get multiple shapes.
Right. Show the. Sorry.
Oh,
the power. I love this.
Yeah, sure. The power feed. I did ages ago a video on this. This machine usually does not come with a power quill feed. I retrofitted one. That works quite well. It has adjustable speed.
And you said an Arduino inside of it?
Yeah, it has an Arduino inside, and it shows the actual feed speed in millimeters per minute.
Okay.
Here on the display.
Yeah.
So like when I need a certain surface finish, I can do my math and go back to the finish via the RPM and the feed. And it has a dock sliding key clutch here, so I can go back to manual feed.
It looks really smooth.
Yeah, and I wanted to look kind of stock, nothing hacked on.
Well, but it's funny. So I met Theo, who I think you know, and it was too funny because it's just funny how small the world is. And he and you have both done the Richard King scraping classes.
Yes.
And he has a smaller version of this, but he has really overhauled it in a very cool way.
Completely.
Which is impressive.
And did a lot more to it, even more.
Yeah, it's really cool. You did, so it's common to do the gas piston, the counterbalance?
It's not really common, but it helps cranking the head up and down. I do not have a power feed or a power rapid for it. But yeah, it helps.
Yeah.
Linear scales on all axes. That's to me, that's absolute given on a manual mill and on a manual lathe. If you want to do any production or precision work in a reasonable amount of time, linear scales are a no-brainer. And with Euro, you have to have it.
And I like the kind of looks what I think of like the windshield wiper.
That looks a bit hacked on. Yes, that's the power feed for the X-axis.
No, it's great. It's really quiet, smooth.
Does what I need.
You'll use it to cut or just for positioning?
Oh, I use it to cut.
Yeah, okay.
If I have to take a long finishing cut, even with a fly cutter or a face mill, I can just walk away.
No problem. Cool. This is amazing. This is such a cool setup.
That's like 1970s technology. That's a Pantograph engraving machine. It's a mechanical copy milling machine or an engraving machine.
A duplicator.
Yeah, duplicator.
Yeah.
Yes, exactly. It can do from 1-to-1 copy down to 50-to-1 reduction.
Yes, it's amazing.
Very high precision. It's an engraver, but it's built to specs like a tool room machine. At the moment, it's set up to cut the Torx head into some titanium screws that I'm making.
Yeah, so check this out. He's got a indexer here with the looks like a 5C style, call it, in there.
Get that out of the way.
And you can see that's at a 0.5 millimeter or approximate.
The end mill is 0.6 millimeter end mill.
0.6 millimeter end mill. And then we'll see in another room, he does have a small CNC machine here. He routed out, this is 20 times?
Yeah, I think it's, 20 times.
20 times larger pattern. Okay, so that's where you set your...
Yeah, you set here on the scales, you set your reduction rate.
Yep. And then it's really cool. He's got the microscope here. It's so slick. And you can actually, see if it comes through on camera. Yeah, that comes through. If I can hold it steady enough. You actually hold this here. We'll see if I can do that and crank the table up a little bit. Actually, I'll crank the head up now. I won't touch the tool. But, you can now see the tool from a distance away, so you're very relaxed, and then you can just slowly move your right hand around that pattern. Am I doing it somewhat correctly?
Yeah, you're going climb milling. That's good.
Cool.
Because
we'll film you. You look at it.
Oh yeah.
Do it
Sure. Usually you sit when you operate the machine. Right hand operates the stylus. Left hand operates table height. And if you do engraving, you have a small C-axis or quill travel here. That just drops down the spindle by 3 millimeters for engraving. But I'm not using that for milling. I'm using the whole table. And basically dropping down 0.2 millimeters for a cut. Then I will trace out the shape like this. Going clamp milling, of course. With large end mills, it gets really hard to hold on. The cutting forces
you feel
are,
it.
yeah.
Sure.
The 20 times reduction helps here too, because you get 20 times more force multiplication. And then you just step down and cut your torques.
That's cool.
As you do.
I had to laugh when I saw this because there's some element of this that's so fascinating to me. And the only other person I know that cuts torques is John Grimsmo on the Nakamura modern C-axis with a speeder, polar interpolation, like probably the exact opposite extreme of how to do such a thing.
This goes up to 20,000 RPM.
No.
With just a rope drive.
Oh my gosh, really?
Yeah, I'm running it now at 9,000 something RPM.
That's incredible.
Because otherwise I cannot keep up with the feed.
Yeah.
I'm making a nice chip that way.
Okay.
I'm not making dust.
Yes.
And just
how often do you break one of those tools?
Oh, they last forever.
Really?
Yeah.
That's incredible.
They last maybe for hours in titanium.
But it's titanium.
Yeah, it's titanium grade 23.
Oh, I don't know that.
That's like grade 5.
Okay.
Just high purity and low oxygen, I think.
Interesting. How hard is it though to train your right hand to be smooth on the tracer here?
Oh, that it takes a little bit getting used to it, because when you go into a sharp corner, when you're in the corner, you have to get out again.
You have to keep moving.
Yeah.
I see. Okay.
It takes a little bit. You can rest your hand on here, and that's okay. For heavier cuts, you would stand up, and you would rest your other hand here, and you would guide it like that.
Oh, really?
Yeah.
That much?
And you would hang on it.
Wow.
And you would use a single flute cutter.
Okay.
That's less cutting force. More flutes, more cutting forces.
Yeah. Interesting.
The larger machines can do 3D tracing.
Oh yeah?
Yeah, you can do one-to-one duplicating, 3-dimensional in tool steel.
Cool.
That's what we used years ago.
Well, sure, pre-CNC era.
In
Okay.
mold making.
Right.
That was before I was a machinist.
Right. No, I've seen that with you, so you would hand sand a pattern or cast a pattern, and then that's the master. Interesting.
Yeah. Then you duplicate it down to your steel mold, for example. That's how it was done.
That's cool.
It's a really nice machine. It has preloaded bearings in all the pivots.
Okay.
So there is no backlash in the pantograph.
It was quite easy to move, though.
Yeah. Huh. It's really well designed. Got this out of an apprentice shop from BMW.
Oh, really?
Close to Munich, yeah.
That's cool. And those are the tracing for characters and letters?
Yeah, that's for if you do serial numbers. You can slide them through. And when you do multiple numbers,
that's awesome.
If you have to do serial numbers that are counting up.
It's sequential.
Yeah, sequential.
Yes.
And then you just move them up.
Makes it quick.
Yeah, that's
like
for round. If you have to engrave on a circle. And that's quite nifty. That's a pattern holder. That goes in here, mounts on this slideway here.
Okay.
Reaches over the spindle in here.
Okay.
Then you can set the spindle to free float.
Oh, so
and you put a pattern on there of a freeform part.
Wow.
Like you cast off the part, and then you can engrave on a freeform part, like D13 does with the 3D probing. But that was way earlier.
But there's some limitation to how much undulation.
Like it has a limit.
Right.
Otherwise you go off the edge.
Right. That's cool.
But I tried that long time ago once, and it works. But I don't need it.
Yeah, sure.
I can do that if I need on the CNC.
Right. Yeah.
That's the second most recent machine in my shop.
Okay.
It's a Knut tool and cutter grinder.
Oh, I've seen that company at tool shows.
Yeah, they are importing from everywhere. And
okay.
I think they built the machines themselves partly too. Well, let's get all this stuff off there. Basically like a surface grinder, has a table with quick traverse, has a wheel head that moves up and down, rotates like this, rotates like this,
lots of,
has a motor driven workhead for cylinder griding.
Okay.
I can do basic cylinder grinding on it. I have down here an adjustable 4-axis workhead.
Okay.
For end mill grinding.
Okay, the helix of a
No, you can't do the helix with it, but you can do, for example, the cutting edges in front.
Okay, the face of the tool.
Yeah, I tried to learn how to grind the front edges of end mills. Some of them look okay.
Yeah.
Some of them look not okay.
So
but they all work. But some of them look really not like they're supposed to.
Got it.
And I use this as kind of a universal machine for oddball setups.
Okay. So you were showing me what I think is really cool is how easy it is to back relieve a tool on the D-bit grinder, but it looks like this could almost be easier, no?
Yes, if it's set up that way.
Okay. Well, isn't it right? Wouldn't you be able to just put an end mill?
Yeah. Right now, I just would put an end mill in here, put the diamond wheel on here.
Yeah. Right.
Let the wheel spin, let the workhead spin, and feed it in like this.
Right. At least seems quite easy.
And that would put a nice neck down.
Got it.
But usually when you walk up to this machine, it's set up for some completely different task.
Okay.
It maybe has the multi-axis head on it. Mm-hmm. This might be swung around in some weird angle.
Got it. Whereas the D-bit grinder is quite easy to get back.
The D-bit grinder takes 5 minutes in whatever condition it is.
Right, regardless. Cool.
So it's a lot of setup work, but it's very universal. Maybe the second grinder. It's a lip.
It's cute.
It's the cutest surface grinder you will find. It's a lip.
Yeah.
It's a French company.
Okay.
They're still around, as they are called Lip Mech now.
Okay.
Small surface grinder, 200 millimeter travel, 100 and something millimeter cross travel, and 100 in height.
It's incredibly small.
It's fully manual. as a Herrick 6x12 basically.
Yeah.
Table travel, traverse, and you have your wheel height here, and it's really a good machine to me.
Yeah.
I scraped the table.
Oh really?
It needed work. It was badly worn.
Mm-hmm.
And
worn is bowed from use?
Yeah, it ground a heavy bow.
Did you have to grind it first, or did you scrape it all
I completely scraped it.
Yeah.
Oh, Biax, that's fixed. That's fast.
Okay.
Scraped it, and now it's running. It's grinding straight as an arrow.
Cool.
It's like 2 microns over the whole length.
Yeah?
Yeah,
cool.
It's decent.
It's funny because the first, when I walked up to it and just sort of moving it, it's so strange to see a surface grinder
It's wobbling on its base. But the machine within itself is rigid enough, so this is not an issue.
Got it.
If you see a vertical machining center and it's moving really fast, it will.
Well, but so we saw that. I mean, the last 2 places I toured were Kern and Hermle, which was 2 amazing companies, and they sort of treat the sheet metal slightly different than the machine itself. The sheet metal is going to have some motion to it, but it's not. But
the machine is rigid enough not to.
It's okay.
Transfer into the machine.
Neither of those machine tools, so far as I know, most of them models aren't
bolted down.
Yeah, not bolted down.
That's commonly not done anymore.
Yeah.
Yeah. None of our VMCs is bolted down. They all
your
sit
day
on.
At your day job.
Yeah.
Yeah.
They all sit on leveling elements.
Mm-hmm.
And
that's it.
Good. That's good enough.
Wow. Interesting. Yeah. I mean, I guess ours aren't either, but the higher end machines, I feel like.
Probably, if you go into the jig borer, jig grinder realm of machines, maybe those. But,
interesting.
But
yeah, sure.
Not sure. The lathe. Everybody loves the lathe.
Everybody loves lathes. I actually like M-code lathes.
Yeah,
acceptable exception.
This is the most recent machine. Bought this 3 weeks ago.
Yeah.
Set it up. Already making production parts on it.
It's funny how much smaller the 11 is than the 13.
Yeah, the 13 is a real beast of a machine
totally
compared
different.
to this. Surprisingly rigid machine for its size.
Mm-hmm.
It's not like an Harding HLVH,
yeah.
which is about the same work envelope.
Yes,
but it
much
weighs
heavier.
about 5 times.
Yes, you have to bring these all down the stairs through there.
Yeah, it comes down staircase with a 180-degree turn.
Yeah,
so
13 wouldn't be fun, or an HLVH.
Yeah, I was considering in Harding, but
yeah, we're almost worth it though, given how awesome those are.
Yeah, sure, but yeah. You have to stay reasonable.
Yeah.
Now it works really well. Spindle is very stiff. Mm-hmm. Has good spindle bearings in it. Mm-hmm. It's almost unused.
Looks great condition.
A model engineer from Munich bought this machine probably in the 80s. New.
No.
Oh yeah.
That's amazing.
And when he died, it got sold off to a machinery dealer where it said it was not really a machinery dealer. He dealt with HO model trains.
Okay.
Motorcycles, old-timer cars,
Okay.
and machine tools.
Yeah.
So it's a very, as you do.
Yeah.
And he sold it for a reasonable price to me.
Yeah.
And
That's
as far as I know, I'm the second owner of this machine.
That's really cool.
And it's a low mile.
You can tell. I mean, it's in the ways look in great condition.
I have the gearbox open. It's all hardened and ground gears.
Mm-hmm.
There is nothing soft in there.
The 13 has a flame hardened bed as well.
This is a hardened bed too.
Okay.
It's rock hard. Spindle is hardened to and ground. It's
Yeah.
really, that's what I was looking for.
Yeah.
I wanted a very solid machine that I can run for years.
Right.
It's very, very quiet for a geared spindle.
Right. That's incredible. Sounds great.
For a geared spindle.
What's with the strange spindle?
Oh, okay. That's a D13 spindle.
Okay.
Same taper as on a camlock spindle, like on a Monarch.
Yeah,
EXN.
the taper that it makes.
It has a short taper and
Okay.
it matches on the flat surface, like an HSK taper.
like almost like a dual contact.
Yeah, like a dual contact
Okay.
or HSK.
Yes.
Sits also on both. But on this machine, it has not the camlock feature, only the taper.
I see.
So you put.
How do you bolt it then?
Oh, let's get a 6-jaw here.
Yes. Yeah.
Preferred style of chuck now. I had this for 2
Spoiled.
years, and it's great. I can't put it on because I have to collet reducer.
Oh, so they
here.
use the nuts in behind it.
You put it through the holes and you put 3 nuts on the back, tighten it down.
Done.
Very safe method of mounting a chuck.
And sufficiently repeatable and locate zeros.
The taper will repeat it perfectly.
Right.
When you machine a taper for this nose, you make it that way that it hits on the taper first.
Okay. And then pulls into the flat.
So exactly. You have about 10 to 20 microns gap between the two faces. And when you tighten down the bolts, it will go on.
Interesting.
And make full contact on both the taper and the flat. So you have a very rigid connection.
So there was I think it was an Instagram sort of challenge between Stefan and Marvin. So we filmed at Kern yesterday, and Marvin interpolated on a Kern Micro, I believe.
I think so, yes.
He interpolated probably a 2-inch ring that has an HSK 40 taper to it. And then we took it to their Zeiss CMM and measured. It was, I think, 2 different strategies. The interpolation strategy, though, I think was 1.9 microns of circularity run out.
1.9 or 0.9.
Yeah, maybe that's what. Sorry,
Yeah.
no, I missed it. We'll correct that in the text right here. So you're trying to challenge to see if you can outdo that.
This machine will not do it.
Okay. That's so crazy.
The spindle bearings on these are P6 tapered roller bearings.
Okay.
It's a higher grade of tapered roller bearings, but probably not good enough to match this tolerance of roundness.
Okay.
But on a high-end lathe, like Hardinge, a Schaublin 135, that will
No problem.
no problem, or a Suhnkel grinder.
Oh, sure.
But you have to consider it's XY interpolated. So
incredible.
That's crazy good.
It's incredible.
It's really.
You're right. And the test that we did had, I think it was 4,000 or 5,000 points.
4,000 points.
So it wasn't like they were cheating with just certain quadrant checks.
No, I talked to him about that too. But I will do a test part and we'll have it checked on a CMM with the same parameters.
I like that.
4,000 points.
Okay. We'll keep everyone updated on that.
Yeah,
That's
I
very
hope
cool.
so. Oh, this will be embarrassing. But I don't expect this lathe to cut that round.
Yeah.
The roundness tolerance on these bearings is like, I think they are spec'd to a max of 4 microns.
Okay. Got it.
Usually they are better.
Right.
If you buy bearings from a decent manufacturer, they are usually better. They do not use the tolerance at all.
I like that. Putting the drill on the on your tool holder, so you're drilling with your cross slide.
I'm drilling with the carriage, yes.
Yeah, that's great.
With small drills,
Yeah.
the hand crank tailstock, it takes forever. You have to drill a deep hole.
Yes.
This is way faster, and you have the benefit of a Duro
sure.
depth control.
Right, that's great.
This is reading 5 microns in the depth, and 2 microns on the diameter.
Yeah, that's
So you need that.
Yeah.
The well-known 4x6 bandsaw.
Modified for the vertical?
Yeah, usually it's a horizontal bandsaw that can be used vertical, but I don't need a cutoff bandsaw that much. So, and it needs very much space that way. So I threw away the base, mounted it on a large stand, and I'm using it vertical. And the keen observer might see this here. Yeah. Normally they have a small gearbox, a motor, and a belt drive.
Yep.
I rebuilt that gearbox a number of times, and then I got sick of it, and I bought a proper industrial geared 3-phase motor, hooked up to a VFD. Yeah,
that's awesome.
And this
I can only imagine the low speed torque this has over. Wow, look at
and this gives me quite a large range of speeds.
Yes.
So
that's awesome.
It works for wood and for tool steel.
Has anyone ever tried to modify this to have a sort of a modified infeed design?
Oh, like a roll-in saw.
Yeah.
I want to do this on this one.
Right. You could build a bearing stack.
I want a sliding table for this with a gravity feed.
Right.
Yeah.
That'd be awesome. You could even have a counter, like a pneumatic counter assist to
control
it.
Yeah, to have a chip load, a defined chip load.
Yeah. That'd be cool.
Like on the roll-in saws where you can cut like thin sheet metal with such a coarse blade.
Right.
That's one thing I noticed.
It's very coarse.
A lot of people keep a super fine blade on their 4x6 bandsaw, like a 10 to 14
TPI
blade. That's very common as it seems, but it takes forever to cut heavy stock with it.
Right. I think people can. I think it's maybe even a misperception, but it seems to be with these teeth, it's easier when you feed too fast to then chip one off, and as soon as you chip one, it's downhill from there.
Oh, it's not a problem at all.
Yeah.
Yeah. With such a rough blade, torque is more a problem.
Okay.
The bandsaw, you will stall it out.
Yeah.
For sure.
I don't think you're going to stall this thing out.
I cut.
Really?
Yeah. This is what I cut recently. This started out as a round chunk of
oh my gosh,
of cast iron.
Wow.
And I needed a square block for a solid tool post to replace the compound slide on this lathe.
Oh, cool. Yeah.
I'm doing the full Rensetti.
Right. I like that.
And all I could get was a round chunk of cast iron, so I had to bandsaw it square. And a cut of this is 80 millimeters.
Like 3 inches, 4 inches, yeah.
Yeah, and 120 millimeter length takes 3 minutes.
No.
Just push it through. Goes fast.
Wow, that's not bad at all.
No.
Well, so I can certainly see having I think the rule of thumb I've heard is you want 4 teeth engaged in the material.
At least, yes.
Yeah.
Basically, this blade is too fine for this heavy stock.
Really?
Yeah, but you cannot get a rough, coarser blade in this width.
Right. That's fine.
So I'm stuck with that. But it works for my purposes.
Yeah, sure.
And for me, band sawing is in a lot of cases faster than milling. If I can...
Yeah, you keep a scrap too.
If I can mill away this chunk of material. Right. And I can make, for example, a tapered gib out of this small one. Do a lot of rebuilding of machine tools or small machine tools. And you always need to make new gibs for them.
Why would you choose between cast iron and brass on a gib?
Cast iron is just the stronger material. It's a little bit harder. It's very resistant against pressure. And you can hold it on a magnetic chuck.
That's nice.
Breast sticks badly on a chuck.
Yes.
yeah. Quite bad. You can super glue it down.
Does it change the turkite that you would use with whether it's brass or cast iron?
You mean one side turkite, the other one brass?
Correct. Does it matter?
Good question. Not sure.
Okay.
Wouldn't probably matter.
Yeah.
The turkite will probably wear slower than the brass over time.
Really?
I guess so.
That's crazy.
I guess so.
Slow turkite wears.
It's just in a lot of cases the softer material wears slower.
Okay.
Or the plastic wears slower than the metal. If it embeds any grit in it, it won't hurt the turkite, but it will hurt the other side.
Interesting.
We see that a lot if we make like guide rails out of HDPE.
Yes, sure.
and we have a metal part sliding up against it, the metal part will wear.
No,
Oh,
really?
true. And
That's
the
crazy.
HDPE, we have the Murtfeld, that's a very slippery green plastic with Teflon in it. It will not wear at all.
But it's funny because you can take a pocket knife quite easily.
Yeah, sure,
and carve.
you can carve
Yeah.
figures out of it,
It's funny.
but the plastic will not wear.
You know, it reminds me too. We've started playing more with the IGES products or IGES.
Yeah, sure.
And similar.
Those
thing.
are great. They will not wear.
Yeah.
We always make fun of them because at the trade shows they always have this test rig
Yeah.
with dirt in it and linear slide and running just dry and dirt, and we always made fun. Oh, you have to lubricate them with dirt.
See the Germans have a sense of humor. It is
we
funny.
have a little bit of remaining sense of humor.
Yeah, it's funny. What's over here?
Demagnetizer.
Yeah.
You need that for if you do any surface grinding
Yeah.
or generally in a shop. Stuff gets magnetic.
It was funny when we hosted our last Richard King scraping class.
Stuff gets magnetic.
He was furious that we didn't have a demagnetizer until he overnighted one from MSC, and he's a character.
Yeah, that's good. Yeah, you need one. And the scraper blade gets magnetic. It's super annoying.
Yeah, sure.
I have the.
Oh, that's the.
That's the Moore
That's
rotary table.
incredible.
I think that's the same that Adam showed at Superb.
Yes. No, his is bigger. His was
Is
not
it?
the right size for their jig grinder.
Really?
It was
bigger one?
probably 50% bigger. Yeah. That's awesome.
This fits actually
Look at that.
pretty nice on the RF45.
Really? Did you flake that?
No, that's
That's from
stock.
them. What's that?
That's stock.
That's beautiful.
I
gosh.
bought that from my day job.
Yes.
We had a Moore number 3 jig grinder that got sold off.
You should have bought the jig grinder.
Yeah,
Or you would put it,
I
but
could put it in the garden.
yeah.
put a tarp over it. But I bought the rotary table and the 1, 2, 3 blocks.
Cool. Oh, so you have a set of more 1, 2, 3
I
blocks?
have the full set of. I can show you.
That's very cool.
Yeah, the foam is disintegrated, but the blocks are
Yeah.
all very nice.
Look at that.
And even the smaller ones, I have the full sets of imperial screws to go with it.
That's cool. So these are the folks that wrote the book, Precision, or it was
Yes.
Fundamentals of Mechanical
Yes.
Fundamentals?
Fundamental of mechanical accuracy,
Accuracy, yeah.
and whole surfaces and contours, which is Foundations of Mechanical Accuracy is a great book if you want to design or rebuild a machine. Holes, contours, and surfaces is written for the machinist.
I've heard it's a more difficult, it's more dense book, a little bit less
It's
fun to read.
great
I
if
guess.
you run a mill, a jig borer, or a jig grinder, or a surface grinder even.
Yeah.
There is a large portion of profile grinding in it.
Okay.
The fundamentals of running a jig borer, you can use a lot of that skill or that knowledge or that technique on a mill.
Yeah. Sure.
Factor 10 less precise.
Sure.
But the principles stay the same.
Yes.
It's also a C-frame machine with a spindle that goes
Right.
up and down.
Right. I was interesting when we saw at Superb Industries and Adam talking about the, I forget what the term that they used was, but there's a heater to keep the
There's
spin.
a heater element in a jig borer, yes.
That's so cool.
It has a small thermometer.
Yeah. Keeps the spindle at a constant
It's
temperature.
crazy, those machines.
And that was the Kern tour. The Kern was basically all about the thermal stability and the thermal cooling loops and the sensors. It was amazing.
I use the Moore blocks here on the surface plate quite a bit. And what I also got... Obviously, I use it all the time. I got this with it too. This is a centering microscope. It's also from Moore.
Yeah.
Goes in the spindle.
Yes.
This has the mounting to go on the jig grinder. But you can take this plate off, and then you can just mount a shank to it and hold it, for example, in a mill or in the tailstock of a lathe.
And that will help you find center of a tool or a drill?
Sure.
That's
and
cool.
on the mill, you can use the mill as a toolmaker's microscope.
Oh.
You have your DRO.
Sure. Oh, look at that.
You have an XY table.
Right. That's really cool.
And you can do a lot.
Well, and with having scales, you don't care so much about the quality of the machine tool.
The lead screws are really not that great on that machine, but the linear scales are.
It doesn't matter. Yeah, right. That's cool. I like that.
You can do a lot with that. I have a toolmaker's microscope up here. which only large people can use up there.
Yeah, if it's not quite obvious, how tall are you in feet, inches, do you know?
Whoa! I'm 2 meters and 30 millimeters.
Okay, we'll put the conversion up, but I'm 6'1" and he's quite tall.
That's why I work on small parts.
It's funny.
I absolutely enjoy working on tiny or small parts. Everything that's bigger than my fist already gets me worked up.
Well, where's the cast iron part?
Yeah, sure. That's
Yeah.
for. but I can show you a customer part later. The small titanium screws.
Yes.
Those are really small. That's the work I enjoy to do.
The screws that we were doing in the deck.
Yeah, that's what I showed in the Pantograph, and there was a second style.
Yeah, that's cool.
And that's where the toolmaker's microscope is very nice. It has micrometer heads here that read to 1 micron per division.
Wow.
They have vernier scales. And you move the XY stage. You have up here, you have angle graduations.
Okay.
You can rotate to measure angles.
So there's an actual crosshair.
There's a crosshair in there.
It's kind of like an optical comparator, but in a microscope.
It's a cheapo version of an optical comparator.
Right.
Basically. You can do a lot with it. Not as much with an optical comparator, but it doesn't need the large footprint.
Yes, of course.
The optical comparators have a crazy large footprint because of the optical...
it's a TV screen or projection.
Yeah,
sure.
protection.
Right.
Projection. It takes a lot of... What?
This might be the only RF45 with a heat shrink system.
Yeah,
in it,
sure.
Huh? I like that.
I got those for a very reasonable price from my used machinery deal. I don't really need them, but
funny.
they're nice to have and kind of fun.
That's hilarious.
Yeah, but I also have the...
It looks like a beautiful boring head.
The large boring head. This is a Japanese clone of an Wohlhaupt autofeed.
Oh, sure.
Autofeed boring head.
What do you mean by auto feed?
You can do normal feeding by spinning this
Really?
here. It will move it.
Yeah.
Or you set it to fine feed, let it spin in the machine, and you hold the ring,
No.
and it will auto feed and auto face that way.
Really?
You can do, if you have a part, you bored the hole,
Yes.
then you want to face the bottom of the hole.
The backside, basically.
Yeah, or the bottom of a hole.
Yes. Oh, sure.
Or a flange surface of a round part, you want to face it.
Yeah.
That's what you use.
Anything to avoid a lathe.
It's basically a lathe.
Yeah, right.
It's an inverted lathe.
Mill.
Yeah.
That's great.
Yeah, you can do a lot of it. It has a clutch on the inside. You can set the stop with
they
cage
kick
blocks.
out.
Yeah,
Oh,
they kicks
wow.
out.
That's cool.
You can do internal snap ring grooves with it.
Okay, sure.
Which you would do on a CNC with a wood roof cutter and interpolated XY.
Right.
You can use this to single point it.
Right. That's really cool.
Yeah, that's a very nice tool. This is the large one with Morse taper 4.
Which is that spindle?
Yeah, that's a Morse taper 4 spindle. Usually I have a Morse taper 2 reduction in it because I use a lot of small tooling. And I use a lot of Morse taper 2.
Right.
And I have its little brother. That's a Wohlhaupt UPA1 boring head. It has also auto feed. It can also do so facing and the adjusting with the ring here. You do not need a wrench like on a Criterion boring head, which I find quite annoying with the wrench to adjust.
Yes.
These have a graduated ring that shows 10 microns in diameter, and if you set it 10 microns larger, it will move exactly that. It will. Right. It's spot on. These are incredibly well made, all hardened. There is no soft part on this except for maybe the screw here, and they're just well built.
I love that idea of setting gauge blocks offline and then coming up to a blind ID feature and
just
clutching out.
Move it out, kicks out, and you
bring it back.
Bring it back before you retract it.
Hopefully.
Yeah.
Well, yeah.
Otherwise, it crashes a little bit. Yeah, that's just random tooling.
What's that in the back corner?
That's for a job I did. I had to make plastic parts that had 30-degree V-grooves in it, long parts.
Oh, interesting.
And I made this inserted cutter here.
Look at that.
This is shop made.
Yeah.
And I reground these inserts. These are VCMT lathe inserts.
Yeah.
I reground them to 30 degrees.
We call that modified IC.
Yeah. And I run this like this.
Yeah.
And I have the plate like this here in the vise, and I just move
conventional
it.
or
I tried climb milling. Didn't help much. Then I went for conventional and just use the fork buster and blasted coolant on it.
Did you blue it?
Yeah, that's cold blue.
Okay. Oh,
If cold blue is done properly, it looks really good.
Huh.
Cleanliness.
Yeah.
I cook it off in the ultrasonic cleaner with a very basic cleaner.
Okay. Basic meaning not acidic.
Yeah.
Okay.
The
Your
opposite
English
of-
is very good.
Thank you. And then wash it off with isopropyl alcohol, blow
Yes.
it dry, and use the cold glue directly on
Yeah.
it.
That's cool.
Then you get decent results.
Mm-hmm.
It's just the small things. I run this as a side business, so I have to find ways to do things for a reasonable price,
Right.
but still fast and.
You do treat this as, I mean, I know it's your hobby and you do the videos, but you do treat this as a revenue generating side business.
I'm a legit business.
Yes.
I make enough revenue to be very taxable.
Yes. Okay.
And yeah, I have to find ways to do with the machines I have
Right.
to be profitable.
Right.
Otherwise, it wouldn't make sense to do outside work.
It's just a hobby then.
I don't want to work for $1 an hour.
Right. Right.
I want to have a reasonable hourly rate.
Right. Right.
That's the Pantograph machine is a good example. It may seem like an ancient idea of machining, but I can cut this Torx head in like 1:30 to 2 minutes.
Yeah, it's not bad.
That's decent.
Yeah.
It's a little bit of setup time, but that's calculated in the quote. Yeah, and then we have the bench.
Yes.
I do a lot of bench work. I see that a lot of in CNC shops. They don't have benches anymore, where people do like deburring assembly.
Yeah, well, number one, I would argue that unfortunately, oftentimes benches just collect junk.
As you see.
Well, this isn't bad. No, this isn't bad at all. You need a place.
Should have seen it last week.
Yeah, you need a place to work.
Yeah. I need a place where I can have a microscope. Sometimes I have my CAD notebook here. I need a place to sit.
The Leica.
I got a nice Leica MC6 stereo microscope on a
Oh, that's nice. I like that.
on a stand that I
Look at
made.
that. Yeah, yeah.
It has Egus bushings in here.
Oh, yeah?
Yeah,
You say Egus.
Egus, yes.
Yeah,
I just
Sorry.
yeah.
That's awesome.
They are axially preloaded. There is a hardened and ground pin in them, and I ground the pin a little bit shorter than the actual dimension.
Okay. Oh, so it gives it
So
preload
it
on those
pinches a little bit and it
Got
makes
it.
it a little bit
Little tension.
draggy.
That's cool.
It adjusts very nicely, and it's just a cool microscope.
It's by far, as
It's way more microscope than I ever need.
right.
This is what you would find in a semiconductor laboratory. That's
Oh,
where
really?
this comes from.
Okay. As a self-taught machinist myself, if there's one tool I've found over the last, say, 2 years that isn't obvious as something...
Microscope.
Yes, please. If you're watching this video and you love this trade,
Get a
go on
microscope.
eBay or Craigslist. Buy a cheap one at first, because a cheap one is fine.
The M scopes.
Yes, well, those are
Okay,
$1,000.
those are still money.
But for $100, you can probably
Yeah.
find a microscope somewhere.
a stereo microscope, that is.
Stereo will give you so we have both. The stereo microscope will give you that three-dimensional depth, which I would agree is really good. The video can be really helpful for showing other people or
a video microscope, yes.
Yes, you don't have that depth though, for
Yeah.
sure. So deburring, you want the stereo,
Yeah.
no question.
Or get a Mantis Elite.
yeah.
Those are nice too.
The 3D vision technologies.
Yeah.
Yeah, they're like $7,000.
I got one at work.
Yeah,
They're cool for deburring.
yeah, that's really nice.
Work under them. But for actual magnification, they're not as good. I have a 4 times and 8 times magnification on mine at work.
Yeah, it's not that much.
It's not brilliant.
Right.
But it you can sit in front of it for hours and
Yeah.
it doesn't fatigue you at all.
Yeah.
Speaking of microscope, the second best thing is, if I can find one, get some magnifiers. get small.
Yeah, the loop we call.
Yeah, loop.
Yeah, yeah.
Get these.
Yeah.
Buy a bunch of them.
They're cheap.
Drop them everywhere.
And don't place them everywhere.
Yeah. 8 times magnification. Look at end mills. Look at cutting
Right.
edges. Look at everything.
Yeah.
It-
I like your setup here. He modified one. These are like probably a 5-pack for $10.
Oh,
But-
these are the El Cheapos from eBay.
Yeah,
Yes.
a little Noga base, 3D printed finger clamp, and then just sets in there. And it's genius because you can actually be, again, 2 feet back from this and have it angled
Yeah.
like a scope, and it just
And you don't have to be crammed over the machine like and killing your back,
Yeah.
which is for me often the case. So yeah, magnification. This is actually the lens of a large. This is of an optical comparator.
Really?
Yeah,
That's funny.
and the optics in this are crazy good. Has no distortion at all to the radius. And this is a very good loop, but you can't get that right away. But cheap magnifiers are cheap, so get some.
Agreed.
Learned that very early at work.
These are those screws you were just doing?
Yeah, that's the parts I'm doing at the moment.
I like the insert box storage.
Yeah, I saw that, and they are numbered.
Oh yeah.
Because I have to give a measuring protocol with everyone.
Serious? Like an inspection sheet on each screw?
I have to do basic inspection on them.
Wow.
Some dimensions.
Yeah.
Write them down.
So the job shop work you do is high end.
It's
very
not.
tight.
It's not super high end, but it should be done properly.
Yeah, sure.
It's not anywhere near than the job shop of Kern.
Well, yeah, that's literally probably one of the best job shops in the world. They had this is incredible. We saw I don't know the diameter, maybe 0.2 millimeter, 0.3 millimeter machined turbine impeller pump that goes at 1.1 million RPMs.
Yeah, that's crazy.
You couldn't even see, to pick it up with the tweezers was difficult and would have crushed it. It's incredible.
Yeah.
I don't even know how to describe it.
No, I'm not doing that high end work.
Well, yeah, sure.
But I'm doing relatively small parts for the most time. And these I can take a pair of tweezers. I find some.
It's a threaded feature or just grooves?
Oh, that's 0.35 millimeter fine thread.
Okay.
I have the thread gauges here.
Oh, cool. Look at that.
That's the no-go and the go gauge.
Yeah.
That's the problem with that work. You have to buy the gauging and the test equipment.
Yeah.
Nobody has this gauge ring on hand.
Right. Right.
You have to buy it. Yeah, that's all machined on the MCO.
Yeah.
The Torx head is machined on the Pantograph machine.
And how did you do? It looks like it has 2 different diameters and then taper between it.
Yeah.
So, but it's not CNC.
No.
I don't understand how you would ever do that without CNC.
The small diameter. The small diameter is and the taper are cut with a form tool in one pass.
Oh, really?
Feeding in, yeah.
So you feed in axially with a form tool.
Yes.
That prevents all the load of a. Okay, interesting.
And that also gives me the very tight run-out tolerance between the taper shank and the cylindrical diameter.
It's almost like a topping insert where you cut the crest and the root of the thread at once. It's guaranteed to be good.
It has to be. It has to fit.
I like that.
Yeah.
Okay.
And then the larger diameter is just cut with a normal DCMT insert that's ground sharp on top. I took the insert.
Is that common with titanium to have a neutral rake?
I'm not sure how other people do it, but it's slightly positive ground, but to that sharp edge. Okay, you want that sharp. Normal, a molded insert has a little bit of an edge radius.
Yes.
So it lasts longer than half a second.
Right.
But on, but on small and micro machining, you can get away with a sharp edge.
Got it.
If it's ground with a very fine diamond wheel.
So will you actually take like a DCMT? DCMT. Will you grind an insert on the D-bit grinder?
I do that very low key. I can show you that.
Yeah. Yeah. Show.
I need to get the tool. I have the DCMT. That's already ground.
Look at that.
It has a little.
That's
it's almost
hilarious.
like a tiny chip breaker.
Right.
And
right.
I could grind the tool from solid too.
Sure.
Just a solid carbide shank with geometry.
Sure.
But I want the 0.2 millimeter nose radius of the insert because it's done very good. Mm-hmm. It has a very precise radius already formed on it, and I cannot do that.
Don't reinvent the wheel.
Very easily. Yeah, exactly. Don't reinvent it. And normally this insert has a chip breaker geometry on top, which makes sense if you do production. Sure. But I don't need that for very short passes. Right. So I take. In other words, you're saying bird's nests are okay. Yeah, I just take the bird's nest and throw it away. I can get in there with a tweezer or just with finger. Right. So short of. Don't touch into your chips. Right. Otherwise, we will get sued. The grinding is very basic. I just turn on the grinder, have a D40 diamond wheel, which is very fine. 40 grit, is that what it would be? No, that's 40 micron diamond
Oh,
grit.
okay, that's quite.
That's
still quite
another
fine.
scale
I see.
of grit designation. And then I just rest my hand somewhere.
You do it by hand?
Yeah, sure.
No.
Sure. Yes, you do.
That's hilarious.
That's my manual roots.
My gosh.
I do a lot of offhand grinding. Like
Wow.
that. I as you see, I don't have a rest where I put it on.
Right.
I just, whoop,
It's
grind it flat.
Yeah.
Look at it. Take maybe a magnifier. Look at it. It's good. Yeah.
I like that.
Ready to go. Takes a few seconds.
I've never thought to grind a cemented carbide insert
Oh,
before.
a lot of the guys who do manual and small work do that.
Sure. Interesting.
The Swiss guys, Swiss lathe guys, those have inserts that are that sharp.
Okay.
They have the Applitech inserts, which are ground razor sharp, honed edge.
Interesting.
But those are expensive. And
Yeah.
these are titanium inserts for titanium, which I wouldn't need in this case because I'm grinding them anyway.
Well, that's what's funny. You're grinding off the coating and the edge breaker.
These are even uncoated.
Oh, is that right?
Yeah.
Okay.
These are uncoated inserts.
Got it.
I use them for if I have to remove a lot more stock. I use them with the chip breaker, of course.
Yes. Sure.
Feed them with the correct feed per rev,
Yeah.
and they break the chip very nice. But on these small parts, I need very low cutting pressure, so I can get my fit without spring passes or anything.
Right.
Then I do the threading on these parts. These are all single point threaded on the lathe.
You grind that insert?
Yes, of course.
Oh.
I ground.
Yes, of course. Show off.
I looked in the tooling catalog.
Yeah.
Hoffman Group. They do not have a single point insert
Small enough.
for 0.35 millimeter
Really?
pitch.
Yeah.
It starts at 0.5.
Okay.
So I ground.
So a 0.5 would have too much of a radius to come
Yes.
to the sharp point.
Exactly. And if I can. Here it is.
Look at that.
That's
Oh, it's beautiful.
It's basically
It
just
looks
like
a D-bit.
like a D-bit, like
Right,
an
right,
engraving
right, right.
bit.
But it does have, oh, look at that block. It's beautiful.
And it's just ground out of an old micrograin high-speed
High-speed
carbide end mill.
We will spare you the long conversation, but there's just suffice it to say that there's no need for high-speed steel left anymore. All carbide.
Yes. If you tell me that high-speed steel can be ground sharper than carbide,
Yes. We're going to disable comments for this video.
that's a good idea. Oh, this will get flamed.
Yes. Or actually, if you have to have read a book by Moore to be allowed to comment. How about that? How about that?
But basically, you can grind carbide as sharp as high-speed steel.
Yeah. We've heard the same thing from Sandvik helical tool.
Yeah, they should know.
Yeah.
And if you take a new D13 single flute carbide end mill
They make really nice tools.
with the polished flutes, you will be able to take off hair off your arm with it. They are razor sharp.
I can do more than that, I assure you.
Oh yeah, but you cannot do that with a high-speed steel end mill. I have some here. They will not cut. I will not put a shave on my arm.
I will say this: I've learned carbide is not all the same.
Oh,
how it's sourced, how it's sintered, the mix, the grade, the micrograin structure of it. So don't think all carbide. It's not just carbide is carbide.
There are very rough grades of carbide that you can see the grain structure almost by eye.
Yeah.
And there is micrograin or ultra fine grain carbide that has below submicron grain size.
Yes. Yeah.
And the problem with high-speed steel is you will burn up the edge if you sharpen it to a dead sharp
You
point.
can't hold the heat anymore.
No,
Sure.
it burns up and you round the edge over in a hurry. So carbide it is. Then there is a second style of these parts. This is the second style. It's basically the same part, just a little bit longer.
Oh yeah, look at that.
It has a hex milled on it, just
Okay.
to go on with a wrench. It's
Wow,
drilled
look at
all the way through, almost to the
No.
tip,
Yeah?
with a 1.4 millimeter drill,
Look at that.
and then cross drilled with a 1 millimeter drill.
Wow.
That cross drilling is done on the RF45.
Is that right?
Yeah, sure.
It's a really good example. We all kind of joke, but
Of course
you
it's a
don't
chunker.
need a huge shop. You don't need a
this-
Schaublin to do.
No, I can cross. I use a good quality drill bit. I
Yeah.
use a good chuck. I have a small Albert chuck.
Yes, the finger chuck.
Not even the finger chuck.
No?
This is just a
That's cute.
regular chuck without. It's just held in a 6mm collet. That just drill with the normal.
Yes. There are gradations though on this.
Yeah, sure. If you have to chuck very tiny drills, you can almost preset the chuck to a diameter.
Oh, interesting.
I never needed that.
And now that 1mm drill, is that carbide or is that high speed?
That's a high-speed steel.
Okay.
Coated with titanium, aluminum nitride, blah
tin,
blah blah.
or the gold color.
Yeah. No, the blackish.
Oh, okay, okay.
With a high helix, like a 45-degree helix, and stub length. And I split the point under the microscope with a small ruby stone.
Okay.
So I do not have to spot drill
it. Sure.
It just starts on point.
Yeah.
I will do a video on
Keep
this.
it short. Okay. Cool. Oh, awesome.
Yeah.
Awesome.
I cannot tell what the parts are for. Of course, I cannot show the drawings.
Yes.
But I can show the process of making them.
Cool.
This is quite interesting.
While we're over here, I have to show. This is one of the coolest things I've ever seen, and Stefan doesn't like it, so I have managed to make a deal with him to take it home with me. Look at this.
This is the ancient.
I love it. I love it. I can't believe it doesn't say East or West Germany on it, though. That's the only thing I think is funny. It looks that old in a cool way.
It's heavy. It's really heavy. It's a die-cast housing.
Yeah. Different, totally different style as well.
Yeah, they have a tapered shank.
Okay.
That just slips in
and
seats.
Okay. I guess we can't break that one because I don't think we'll be able to get replacement.
Might be a problem.
Yeah, it's funny.
I have to look. Maybe I have 1 or 2 replacement tips for it.
Maybe better if we didn't get a replacement tip. It will.
Yeah, and that's just.
Oh, is that shim stock?
The round boxes.
Yes.
Yes, sure.
Oh, that's brilliant.
That's
Look at that. Oh my God! Why have I never seen that before? I thought of that.
You need that
That's
all the
great.
time. You need that for scraping when you check.
Oh yeah,
you need
sure,
that
sure.
for on machines if you have to shim something.
Right. Oh no, I know what the shim stock's for.
Yeah,
The way it's always a mess.
Yeah, but a lot of people don't stock it.
Really?
Yeah. I came to a lot of shops that do not have shim stocks that have.
Oh yeah, no, we do. We have plastic and metal and brass and stainless.
The plastic one is great from Applied Precision.
You just buy a whole pack. It's all rainbow colored.
Yeah, exactly. That stuff. I almost prefer the plastic shim stock.
Yeah, we use it if we've had to shim machines or grinders because it just works.
Because in reality nothing is perfect. You have to shim stuff, even if people won't accept it sometimes. That's just all the things that I need on a regular basis. Small electric die grinder, soldering iron, just small parts.
Cool.
Because it's getting harder and harder to pick up stuff. This a magnet on a stick. It's stupid, really. But you use it all the time, and I have it handy. Same for a mirror on the stick.
Yeah, we do the mirrors.
Yeah, I have a die grinder. A Biax die grinder here, always ready to go.
Interesting. I like that.
With a carbide burr for deburring. It's so fast. You can put a very clean chamfer on a part that you don't want to put on a machine.
Yes. Interesting.
Or you just need to botch something and open up a hole or make a slot, or it's just always at the hand. It's 60,000 RPM, so
60,000.
Yeah.
Wow.
Takes a ton of air.
Yeah.
The compressor in the room next door will run constantly with this thing. But I use this a lot. Our tool makers at work all have these and use them all the time.
We have the Fordham tools are quite popular.
The flexible shaft ones.
Yes.
Yeah, those are.
That's what's interesting. You have your pneumatic motors in the handle there,
Yeah.
so you don't have a separate body like on the Fordhams.
Yeah. But Fordham have a lot more torque.
Ah, okay.
If you want to
you don't need the torque usually.
If you do polishing, you sometimes need more torque.
If you have a larger diameter.
Yeah. The duck guts would be an NSK handpiece. These are micro motor hand pieces, electric, go from like 1,000 to 60,000 RPM and have a ton of torque.
Interesting.
But they are like $1,500 for the control unit and the hand piece.
What's it called again?
NSK.
NSK
hand piece.
Interesting.
Or micro motor hand piece.
Yeah.
Peter Stanton shows one sometimes.
Okay.
It looks almost like a tiny Dremel.
Yeah.
But it has 1,000,000 times more power.
And 1,000,000 times less run out.
Yes, that's true.
That's funny.
Yeah.
Cool.
And that's just another wall of tools. I have to utilitize in this relatively small shop. This is 4 by 5 meters, 20 square meters. I have to utilitize every corner, like clamps. I have some of this quaint twist style.
Yep.
Just, I noticed that the quaint twist clamps have a regular thread on here.
Yeah, that's an Acme. We call it Acme.
Yeah, that's
it's home. They're always just a standard.
That's way
stronger. Oh yeah, it's interesting. Huh. And we've a number of ours. We've just because of the way you use them, they'll get nicked, and then you've got to thread file it and fix it.
That's just one thing that I noticed when I saw the quaint twist on YouTube. Maybe. Yeah, camera equipment because YouTube.
You still edit your videos all yourself?
Yes, I do all my editing myself. I film everything with a DSLR, which is an absolute pain.
Yeah, the focus or the.
Yeah, I have to focus.
This guy was it? It was over here.
It's over there on the Engraving.
Ah, yes, there we go. No go now. I like that. Cool.
It's an absolute pain to film with it, but the video footage you get off it is really good.
Yeah. I was very upset when I met ClickSpring and he uses a really old, pretty low quality camcorder. Yes, camcorder.
A camcorder is brilliant for filming. I have one of the old Sony, what's they called?
Handycam?
Yeah, Handycam.
That's funny.
Like this one.
Yeah.
This is what I started with, and I use it from time to time as a second camera still.
It's quite easy. They're low stress, easy to shoot with.
Yeah, and they have a large depth of
focal.
Which the DSLR does not have.
Yes, agreed.
Which is very annoying.
Right. You can't use the footage if it's out of focus.
Yes. Common problem.
Want to show us your the CNC?
Oh, sure. The devilish CNC. Ugh. Yeah.
If it wasn't clear, we are in the basement of your house.
This is the basement of my house. Yes.
And very annoyingly, most or all houses in Germany have 3-phase power. So
yeah, 400 volts, 3-phase, 16 or 32 amps at least.
Well, 32 amps at 400 volts is a lot more than like most houses we would have 100 amps, but only at 200 volts.
Yeah, that's not much.
Yeah,
it's distributed above 3 phases. Then
yes,
you can run quite a grunty motor on that. You can put a VMC here in your garage and power it up without a problem.
That's funny.
Like a Haas Minimal or something like that.
Yeah,
will run without a problem. That's the CNC. It's a router, CNC router, made by Easel, German company. They built all the aluminum extrusions and the motion equipment, like the ball screws and the linear rails, are made in Germany.
Okay. Oh wow.
I got this machine without the controller, just with the motors on it, for a very reasonable price. And then I retrofitted commercial available stepper drivers.
Yes. Like a Gecko system?
Yeah, it's called a Triple Beast.
Okay.
It's German made too.
Okay.
And I'm running it with Linux CNC.
Okay.
Programming is at the moment still done with Fusion 360, but I'm looking to get another system. With CAD, I switched completely away from Fusion. I'm using a Libre Designer now. Got a full license for it. I'm very happy with it.
Yeah. How much is the license?
It's 2.3 kilo.
Okay, $2,300.
Yeah. But I'm very happy with it. I can store my files locally.
Yeah.
That's
that's fair.
I know.
I used to use a Libre. It was great. I didn't like the Geomagic, but it sounds like they're back.
Yeah, it's now again a Libre incorporated.
Yeah.
And yeah.
So what do you use for cam?
For cam, still Fusion,
but
okay. I might go either Sprott Cam.
Okay. It's very difficult. I mean, we use it as well.
Bobcat. No, not Bobcat.
I'd have to defriend you.
I already tried Bobcat. They called me a few times on the phone.
Yes, a few
times. About every 10 minutes.
Yes.
Conda Cam.
What is it?
Conda Cam.
CONDA?
Yeah.
I haven't heard of it. Interesting.
That's a full license for, I think, $500.
Okay.
And it's very decent 3D 2.5D package. let's see what I'm going with in the end.
Sure.
I don't. It's obviously only a 3-axis machine, so
Right. Cool.
I could fit a 4th axis without a problem on it, but at the moment I don't have a need for it.
Yeah.
It has
Cool.
a 24K spindle on it.
Wow. Well, it's common for a router, I guess.
It's a router spindle, but it's a tool changer spindle.
Yeah. This is cool.
It's an ISO 10 taper tool changer spindle, pneumatic.
Oh, look at that. That's cool.
I can preset the tool length.
Right. That's great.
I do the presetting in the machine. I just use a gauge block.
Yes.
Touch off my tools
Right.
with gauge blocks. It's very precise. Takes forever, but it's precise.
And can you get these are commercially available?
Yeah,
Or
you get them
not too
through this
uncommon?
company.
Yeah.
This is Megatron here in Germany.
Okay.
They are selling those The
Mhm.
spindle and the tool changer in this case are it's a 2-part system. It's a spindle with an ER11 collet chuck,
Okay.
which you could use as a standalone unit.
Yes.
And this tool changer just slips
Oh,
over
slips
the
into
end.
that. Interesting. So that's but the drawbar, it's a pneumatic drawbar that
The,
comes
the
through.
drawbar is in the tool changer itself.
Interesting.
It's like a ring piston that goes around the spindle, I guess.
Interesting. So that's just the motor at the top. then.
That's
It's
just
not the
a motor
drawbar.
spindle.
That's
Yeah.
interesting. Wow, look at that thing. That's great. How much are the tool holders?
They are like I think $30
Oh yeah, so not bad.
without a collet.
Right, but it's not crazy
No,
expensive.
it's an ER11 or ER16 collet.
Mm-hmm.
You buy a decent quality Farion or Regofix collet.
Yeah, Fabian's very good.
Yeah,
quality.
decent quality.
Yeah.
And
The costs are twice as much as the holder.
yeah, that's true. And you're good to go.
Cool.
I plan to do a tool changer, rack tool changer.
Oh, cool.
Linear tool changer back here.
Yeah,
but,
Linux will support that no problem. Cool.
which will do a pickup change.
Mm-hmm.
But for now, I'm just changing by hand.
Yep. Gosh, back in my New York TEG days, that was the big downfall. Was it was an ER16 spindle, so you had no tool.
It's quite annoying if
Yeah.
you have to touch off. And Linux CNC doesn't allow to tool touch off during runtime.
In the middle of a program.
Yeah.
Right. Same thing with Mach, whatever.
You have to split the program up in many programs if you do multiple tools, and that's super annoying.
Right. Cool.
Fusion gives perfect G-code for Linux CNC with the tool change code.
Mm-hmm.
It reads the tool library, it does everything as you would expect.
Yeah.
So that's going quite nicely.
Cool. Oh, that's your air compressor?
Oh yeah,
Cool.
that's one of those silent air compressors with the 2 membrane pumps.
Yeah.
It's-
That's enough air for. I guess you don't really need a lot of air.
Yeah, I think California Air
Yes.
in the US sells the same style of compressor.
They're not even that expensive.
No, it's very reasonable, and
Yeah,
it's
yeah.
oil free, so
Okay.
I do not get a ton of oil in the compressed air, only a ton of water. But these are okay-ish.
Yeah, that's not bad. Although it's kind of. Well, I'll see if I can take some pictures on my way out here. So we're in this beautiful town up on this hillside in quaint southern, sort of southern Germany still.
Yeah, it's
But you don't have a neighbor that would be a problem with noise. Here.
no, this is far enough away from
Yeah.
the property is large enough,
Yeah.
so he won't hear it. He won't hear either if I do heavy milling on the R45
Right.
with a face mill or something like that.
Yeah.
Doesn't- If I have the window open, it will. You will hear it outside.
Yeah. Well, a big thank you to Stefan for taking the time, showing us the shop.
Absolutely.
It's been good. We got to meet you at EMO, and it's cool to come here and see his shop and the little nuggets you learned. Hope you folks learned something. Hope you enjoyed. Thanks a lot.
Thank you.
Take care.